Hello geometry students, welcome back to the final episode of this Unit 5 study guide video. Yes, I said final. I'm going to give you a 2-for-1 special. We're going to do both problems at the same time. Well, one after the other, but in the same video, okay? The first problem says, a board game manufacturer wraps its game boxes in plastic. Its most popular game comes in a box that is 8 centimeters tall and uses 1,408 square centimeters of plastic wrap. The company sells a travel version of the game in a box that is a dilation of the original box. The travel version uses 198 square centimeters of plastic wrap. How tall is the travel box? So how tall is the travel box? All right, so let me pull out my calculator. Let me have it handy because I am going to be needing my own calculator for this. So I want to know, well, first of all, a box. We're dealing with a rectangular figure, right? It's a box, right? It says that we have a plastic wrap that uses 1,408 square centimeters. That square centimeters lets me know that we're talking about an area. In this case, if it's wrapping, let's say for example, yes, I have these cans right here. These are being wrapped by a plastic, right? So if it's wrapped on the outside. So that means we're talking about a surface area. So in this case, I need to take, since we're trying to find what the scale factor is and we were given the 198, we have to do 198 divided by 1,408. So that'll give us 0.140625. I want to keep all of those decimal numbers. Remember, when we're dealing with squared units, we want to take the square root, and that will be the actual scale factor. So I got to take the square root of this whole entire thing, and that is going to be equal to, well, let's see what that gives me. I got to take the square root, clear square root of 0.140625. That gives me 0.375. This is my scale factor, okay? Scale factor. Okay, perfect. So if I want to know how tall is the box, well, the original box is 8 centimeters tall. So I just have to multiply that times my scale factor. And that will be equal to 3 centimeters tall. That's how tall my box will be now, okay? 3 centimeters tall. You can write it out as a complete sentence. The box is 3 centimeters tall to make it a complete sentence, okay? Now, let's look at the next problem. It says, draw the 2D shape for the given cross sections of each solid. So if I have a rectangular prism and I draw a horizontal line through it. Whoops, why is there a gap here? There we go. I'm cutting it in half. I'm going to go ahead and see a rectangle as my cross section. Okay. If I have a triangular prism and I cut it vertically, I'm going to go ahead and get a right triangle. I'm going to go ahead and get a right triangle as my cross section. If I take the pentagonal prism and I do a diagonal cut from the top right to the bottom, I'm going to get a rectangle as my cross section, okay? So I want you to notice, if I cut it horizontal, I get the cross section that's up here, right? It's a rectangle. I cut it from top to bottom, I cut it vertically, and I got this cross section here. I cut it in a diagonal way, and I got this cross section here. So hopefully that helps you see that if you're able to look at the angles that are parallel to that line, or the surfaces that are parallel to the line that you're cutting with, that is most likely going to be your cross sections, okay? So that is it for this study guide. Hopefully you were able to understand all of the problems given to you on this study guide sheet. If you have any questions, let me know in class by raising your hand or asking a partner. But feel free to come ask me personally for help. All right. So I will see you in the next series of videos. Bye.